case, visual representation of the data was absolutely essential, and that involved the maps that we generated. So most of our, as I said, most of our analyses did not involve statistical analyses with cut and dried results, but involved looking at maps and looking at the points we had collected and making sense of it based on these other habitat layers we overlaid on those records and what we knew about the environmental conditions in the various areas where these records had occurred. And really the results we presented in the papers we published were maps, not statistical results.
Let's have a look at those distributions now. The historical distributions on the left look different than the current distributions on the right. What do you notice is the difference? Has the population of wolverines increased or decreased over time?
And so we compiled all those records and plotted them out on a map of the United States. And as we overlaid those habitat layers on the distribution points we had collected, we found that the only one that lined up really well was this snow cover layer. There were portions of their range where the vegetation didn't make sense and where these climatic life zones didn't make sense either. But what lined up well and what appeared to be the most important of the factors we looked at was this persistent spring snow cover. So what that means is these are areas that have relatively cold climatic conditions. It has to be cold enough for there to be snow, and snow that not only falls to the ground and sticks, but stays around all the way through mid-May.
Let's compare the snow cover layer to the vegetation layer. At first glance, they may look extremely similar, but looking more closely, you'll see some subtle differences. The vegetation map shows that wolverines have habitats in both vegetation types. In contrast, the snow cover map indicates that wolverines are more densely populated where there's more snow.
One of the really interesting findings from this study so far has to do with the patterns of connectivity of wolverine populations in the western mountains of the U.S. with those further north. The wolverine's primary range is up in the Arctic and boreal forests of Alaska and Canada, and they occur down in the United States in these peninsular extensions in the high elevations of the mountains. So we're basically trading off elevation for latitude to get the same climatic conditions. You have very cold conditions in the far north, and then as you move further south, in order to have the same kind of climatic conditions, you need to go up in elevation. As you lose latitude, you need to go up in elevation to attain the same kind of climatic conditions.
We can see that pattern here in this chart. The x-axis indicates the distance south of a certain latitude. The y-axis shows us the elevation. So as wolverines travel south where it's warmer, they begin increasing their elevation. Why do you think that is? What do you think they're searching for?
One reason we thought it was important to present the actual maps in the papers we published so that others could look at them and see the patterns we found and make their own conclusions or generate new ideas about how to interpret them. They also have become the distribution maps for this species that are used throughout the world. And we've made the raw data from those maps available to other scientists to use in modeling efforts and other analyses they want to do. So, they may have looked at the papers we published, seen the maps, and that generated new ideas for them and new ways of analyzing their data. And that's one way we build science upon our own discoveries and the discoveries of others as well.
The maps referenced in this video appear in the Journal of Wildlife Management. Visit the Natural Enquirer website for more information.